afternoon, everyone. I welcome you up to Dr. Ray class. Let's solve this problem together on motion. A stone is thrown vertically downward with a velocity of 2 meters per second from the top of a tower of height 40 meters. Calculate the A. Height of the stone from the ground after 2 seconds of release. B. Velocity with which the stone will hit the ground. And C. Time of flight of stone. We are asked to take the value of G as 9.8 meters per second. Now, this question may be confusing for some people, but here we're going to look at it from a point where it can be easy for everybody. The easiest thing to do is draw a sketch of what happened during the motion. And that is what I've done here. I drew this line to represent the height of the standing tower. Now, this line is the top of the tower. And we are told that the height of this tower, I use capital H to represent it, 40 meters. And from where the stone is thrown on top of the tower, it came with a first speed of 2 meters per second. Now here is supposed to hit the ground, but we are asked to find the height of the stone from the ground after the stone has moved just 2 seconds. Remember, to move from here, I said to this point A, 2 seconds. They're now asking us how much distance does the stone still have to fall from here to the ground. The easiest thing to do is write all the equations of motion. Just remember them, write them down, and check which one can I use that will have just one unknown. Of course, V is always the final velocity, considering any distance. U is the initial velocity with which the object started its motion. A is acceleration, and T is the time. So it means the same thing. Of course, S means distance. Okay, I wrote out here that the height of this tower is 40 meters. I use capital H. Now, the height the stone moved from the top of the tower for the first 2 seconds is H1. Now, from where it was after 2 seconds to the ground is H2. Meaning that if we add H1 and H2, we're supposed to get the capital H. And the time for the stone from the tower top to this place after 2 seconds is this. Now, to find the height, you check these equations. Which one has distance, which is height? Unknown. But we have our U. Of course, initial velocity of the stone was given to us as 2 meters per second. Now, there are 3 equations that have U. This one have U, this one have U, this one have U. We are looking for S. We know U. We know T from here to here. And we know A. Our A is going to be acceleration due to gravity because the object is moving under gravity. So we change, anywhere we see A, we change it to G. Okay, we cannot use this because we don't know the final velocity. So we can't use this also for S because we don't know the final velocity. But this one doesn't have final velocity. Initial velocity, we know. Time, we know. A, which is G, we know. Of course, time again, we know. The only one we don't know is S. So that's what we're going to use to find this height after 2 seconds. So let's do that over here. So I'm going to say S equal to UT plus half AT squared. So I'm going to change this H as my H1. That's the height I'm calculating. U2, the time was 2 plus half times G is A, and because it is moving in the same direction as gravity, we're going to use G plus 9.8 times 2 squared. So here we have 4 plus 4 times 9.8 divided by 2, 19.6. So H1 is 19.6 plus 4, have 23.6 meters. But we're looking for H2, which is the height of the stone from the ground. The one we've calculated is from here to here. So you remember that H1 plus H2 is equal to H. You can see that from this diagram. From here to here.